Okay, so now let's look at the second part of this asynchronous assignment. So the second part has us do another look at linear relationships. This is similar to the problem that we worked in class on Monday, but it's a little bit different. So I want you to be able to know the difference. The main difference here is that we have a negative slope instead of a positive one. That's a little spoiler. We'll get to that in a minute, though. So this question tells us that Noah puts $40 on his fare card, so that's going to be an important number. Then it says every time he rides public transportation, $2.50 is subtracted from the amount available on his card. So it sounds like a ticket for this public transportation is $2.50 a ride, and he has $40 to begin with. So this first question asks us how much money in dollars is available on his card after he takes 0 rides. Well, we know after 0 rides, he hasn't spent any money, so he's going to still have $40, right? Once he takes 1 ride, this next question asks us about 1 ride. What we're going to do is subtract $2.50 from his starting total. So I would take $40 minus $2.50. That's going to leave Noah with $37.50. Our next question asks how much money is available after 2 rides. Well, 1 ride took off $2.50. I'm just going to take off another $2.50. $37.50 minus $2.50 is going to leave us with $35. So this next question asks us how much money in dollars is available on his card after he takes X number of rides. If you remember from class, we said X is our variable. X tells us we can put any number of rides into this problem and still get the same answer. So let's see, how much money in dollars is available on his card after he takes X rides? Well, if you've noticed the pattern already, each time he takes a ride, it subtracts $2.50. So how would we do that? Well, if we know that he's starting with $40, so he's starting with $40, and then every time he takes a ride, he's going to lose or subtract $2.50. So we can multiply $2.50 times X. X is our number of rides that Noah is taking. So we can multiply $2.50 times X and subtract that whole value from 40, from our starting value, the number that he put on his fare card before he ever rode a single time. So now let's see if we can graph this. We used a couple points that we found up above. We found that when he took 0 rides, he had $40. So I'm going to go ahead and click that point tool. I'm going to look at 0 rides and put a point by $40. Then we said after 1 ride, so 1 ride, he's going to have $37.50. So let's see, 1 ride, 35, halfway between 35 and 40 is $37.50. After 2 rides, now he only has $35. So let's see, 2 rides, he's going to have $35. See where I found 2 rides down here? And then I put my point right at $35. So I can use this line tool, the third tool from the left, drag it between a couple of my points, and I can graph my line. So what do you notice about this line? If we look all the way down the line to the very end, we can see where Noah's going to run out of money. So we see right here our number of rides. Once Noah gets to 16 rides, he has $0 left on his card. So we know how many rides Noah can take, 16 rides. And where do you see this number of rides on your graph? We see that number of rides where our line intersects the x-axis. So where our line cuts right through, breaks right past our x, our side-to-side axis.